We are almost done with our endogenous processes. Just a few more examples of how endogenous processes are occurring and changing our landscape. So, I have mentioned that there are different ways on how magma is formed. Actually, there is three. So we have your decompression melting, transfer of heat, and flux melting. So first, we have the compression melting. So this occurs because of here, the hot material, the rises to an area of low pressure through the process of the convection. So convection is the movement of magma within the mantle towards the Earth's surface. So if you can imagine, since it's deep within the Earth and it's very hot, that's an area of high pressure. So the magma, the molten material from the mantle will move upwards to the Earth's crust, which has a lower pressure. That's why it's called decompression melting. So from higher to lower temperature, and that allows the formation of magma. So this reduction in overlying pressure or decompression enables the mantle rock to melt and form magma. So we can find this points of decompression melting at our divergent boundaries. So when we say divergent boundaries, these are locations where new plates are being formed. So from underneath the earth, you have magma or mantle rock being pushed upward, decompressing, and they break out to the surface of the crust, or they break to the crust. And what happens is new plates are being formed. So magma is moving upwards towards the divergent boundaries, creating new plates, and creates the pushing of the other plates, the other older plates. Okay, so the rifting movement causes the buoyant magma below to rise and fill the space of lower pressure. The rock then cools into a new crust. So decompression melting occurs at divergent boundaries and results into new crust. Okay, next, another location where decompression melting happens is mantle plumes. So if here it's in a sort of layer, like it's a large location where magma could be erupting from the underneath the earth, this one is more localized. So it's just one column of hot rock bursting out from the surface of the from underneath the earth into the surface. So the mantle plumes. So you will see here that you have in the mantle, you have a plume, which you have your mantle rocks being decompressed and being pushed into the surface of the earth. So it's like a volcano even. It's like a volcanic activity, concentrated volcanic activity. And decompression melting is quite significant because this is how Hawaiian Islands is formed. So if you're curious, because Hawaii is very volcanic, like it's made up of islands, small islands, and there is always volcanic activity. That's because of how the Hawaiian Islands are formed. So it's like sort of a conveyor belt, if you can imagine. It's a conveyor belt. Okay, so the Hawaiian Islands, or Hawaii itself, is made up of several islands. You have your Ihaw, Kauai, Oahu, Molokai, Maui, and then finally Hawaii. But these islands didn't exist before. Let's get my marker, so just to be clear. Okay, these islands didn't exist before. Actually, the Pacific plate is always continuously moving. So you have the mantle plume underneath, and then the Pacific plate. So the first formed island is Niihau here. And then because the Pacific plate is moving, it moved towards the left, and the mantle plume continues its activity. It creates another island. So this is one, this is two. Okay? And then later, the Pacific plate moved again, and the mantle plume is once again active. It created the Oahu Island. So same process, the Pacific plate moves, the Hawaiian hotspot is active, it creates Molokai. and then it moves again. The Hawaiian hotspot is active, then it creates Maui, and then finally it creates Hawaii. So we can predict in the future that the Pacific plate will continuously move. Then aside from the Hawaiian island, there will be a new island forming. And we do see evidences of that. We already see these new volcanoes being formed. So the volcanoes here that was once active is no longer active because there is no longer a mantle plume underneath. What is active are those that are directly above the mantle plume, where magma and pressure is coming from the mantle itself. So quite fascinating if you think about it. How Hawaiian is itself a very unique group of islands because of the Hawaiian hotspot which formed the islands. Okay, so just to summarize, magma formation, the first type is decompression melting, which occurs at divergent boundaries and mantle plumes. Now we move to the second method of magma formation, which is the transfer of heat. So very simple, you have a layer of earth which is hot and it transfers heat into another layer of the earth. So you have two plates, okay? So you have two plates which are moving towards one another, and that's called convergent boundaries. So because of the movement of the plates against one another, there will be a heat and pressure as a result of that crashing of plates towards one another. So because of that crashing or clashing of plates, it results to high temperature and the formation of magma forms. So you will have one plate here which will be hotter than the other because usually it's the one moving downwards into the Earth's surface, and it will transfer the heat to the other plate which is remaining above the surface. But still, that convergent boundary will create heat and thus creating magma. Okay, and then we'll have flux melting. So flux melting is occurs because it's more of a chemical reaction. So here it is labeled as flux melting occurs when water or carbon dioxide are added to the rock. So water or carbon dioxide reacts with rocks, and the result is the melting point of the rocks becomes lower, meaning with a smaller amount of heat or less heat. With less heat, the rock will start melting. So you have convergent boundaries here, but because there is presence of water or carbon dioxide, aside from having transfer of heat, flux melting will also occur. So again, it's different from transfer of heat because there has been change in the material of the rock. We added water or carbon dioxide. So by adding water or carbon dioxide, the melting point of the rocks lowered. Then because of that, it starts to melt, creating your magma. So much like heat transfer, flux melting also occurs in subduction zones. So don't be confused when we say convergent boundaries. These are plates that are pushing against one another. But one of the plates may go downwards due to that result, and that's called subduction. So subduction is moving downwards. Okay, so convergent transfer of heat happens at convergent boundaries because they are crashing against one another, while flux melting happens in convergent boundaries, specifically in subduction zones. So you have two boundaries here, two convergent boundaries here. You can imagine the transfer of heat may be happening here, but there is also here the subduction zone, where water or carbon dioxide plays a vital role in lowering the melting point of our rocks, creating magma. Okay, so I hope that's clear for you. So again, decompression melting happened in divergent boundaries, transfer of heat, convergent boundaries, and flux melting happening in subduction zones. Okay, so this is just another picture of or another demonstration of how flux melting is responsible in the formation of magma. So you have here rocks um, which have water and carbon dioxide incorporated in those rocks. So once they completely melt, they react having dissolved gases and volatiles, and they must be released to the surface of the earth. So this is why Philippines has a lot of volcanic activity, because we have convergent boundaries. So aside from the tectonic folding that I have mentioned earlier, we also have subduction plates, which will fuel our volcanic activity.